ourselves around 2 minutes to do that. So we fill in this table, and then later we are going to share what we have written down. Is there anyone who has finished? Is there anyone who has finished and we share our answers?
Yes.
Okay.
Mean odd numbers are written 1, 3, 5, 7.
1,
Even
3,
numbers
5,
are
7.
written. Yes.
Let me first write them somewhere here. One, 3, 5, 7. Okay.
In even numbers are written 2, 4, 6.
Okay.
In prime numbers are written 2, 3, 5, 7.
Okay.
And composite are written 4 and 6.
4 and 6.
Yes.
Okay, thank you. Cedric, your hand is up.
Odd numbers are written 3 and 7.
Yes.
For odd numbers are written 3 and 7.
Yes.
For
Then
even,
for
4 and 6.
Okay.
Prime 3, 5 and
Yes.
7. Then composite 4 and 6.
4 and 6. Okay, thank you very much. Any other who has completed? Okay, Esther.
Odd numbers are written 1, 3, 5, and 7. Even numbers are written 2, 4, and 6.
Okay.
Prime numbers are written 2, 3, 5, and 7. And
Okay.
composite numbers are written 4 and 6.
Okay, thank you. Any other? It seems all of us are giving us the same correct answers. Any other who would wish to share with us their answers? Okay. Now that we have finished filling our table, we go to our next question. Are there numbers that belong to more than one group? Are there numbers that belong to more
Yes.
than one group? Okay, so let's go back. So what are those numbers?
That is 2,
2,
3, 3,
yes,
3 and 5 and 7.
5,
4 and
7,
And
5
4.
and 7, and even 4,
4 and 6.
even 6. Okay,
Yes.
And even
so
6.
and even
6.
okay, so we almost find out that some of these, if it is an odd number, it has higher chances of being a prime number. And even numbers are also having higher chances of becoming composite numbers. So then let's go back to our question 2. How do you identify that a number is odd? How do you identify that a number is odd?
By adding the figures in the number, and if you get a multiple of 3, no, you get 1 and then you keep adding 2.
You keep adding 2. Come again?
Yes. Like we can get an odd number, 1.
Yes.
Then we keep adding 2. You add 2, you get 3. Add 2, you get 5.
Okay. Thank you. Any other suggestion? Esther?
If a number is not divisible by 2.
If a number is not divisible by 2. Thank you. Then Esther? Okay, it seems we have lost Esther. Any other? So we have 2 answers. One of them is that we begin with 1 and we keep on adding 2. That will give us an odd number. And then another one said we get that odd number if we divide, if it is not divisible by 2. So for example, if we got 3 and we divide it by 2, this one will give us 1, remainder 1. So that means 3 is not divisible by 2, and therefore it becomes an odd number. Or if we get 5 and we divide it by 2, this one will give us 2, remainder 1. So that means the 5 is also not divisible by 2, and therefore it becomes an odd number. So if we go to 7 divided by 2, it gives us 3, remainder 1, and therefore it is also not divisible by 2. So we can conclude that we can identify an odd number if divided by 2 and it leaves us a remainder, then that gives us an odd number. So an odd number is not divisible by 2. Then another one, how would we identify an even number? How would we identify an even number?
If it's divisible by 2.
When it is divisible by 2, that is correct. Any other answer?
By skipping the odd numbers.
By skipping the odd numbers, okay. Any other? Any other? Okay. The best one is that an even number is divisible by 2. So when we get a number and we divide it by 2 and it leaves no remainder, then that is an even number. That is the best way to identify an even number. However, somebody says you can skip an odd number. So if it is 3, the next one will be an even number, which also gives us a right answer. But the best one is that an even number is divisible by 2. So examples include, so 2 divided by 2 gives us a 1, so without any remainder. 4 divided by 2 gives us 2 without a remainder. 6 divided by 2 gives us a 3 without any remainder. The next one would be 8 divided by 2 gives us 4. Okay, so we can conclude and say 2, 4, 6, 8, and so on are even numbers, because when we divide them by 2, they leave no remainder. So the best way to identify an even number is to divide by 2, and once that number has not given a remainder, then it is an even number. Okay, another one. How would we identify a prime number?
Prime numbers are numbers that only have one factor.
That have only one factor.
They have 2 factors.
They have 2 factors.
Yeah.
Okay, another
Only.
one. Continue. So they have only 2 factors. Okay, so those factors, one of them is the number itself, and the other one is 1. So what are examples of even numbers, of prime numbers?
2,
2,
So we have 2,
3,
3,
5,
5,
7,
7,
11,
11,
13,
13,
13,
17,
17,
19,
19,
no,
and others. Okay, so 15, we are not including it, because 15 has 1, it can be divisible by 1, can be divisible by 3, can be divisible by 5, and 15 itself. Okay, so that means here it has 4 factors, and we are saying a prime number has only 2 factors. So if we look at 2, it has factors 1 and 2. 3 has also 1
and
and
3,
3. Then 5 has
1 and 5.
1 and 5. So all these ones have only two factors, and one of those factors is 1, and the other one is the number itself. Okay.
Yeah.
Then how do we identify composite numbers?
The number has more than two factors.
More than two factors.
Okay, numbers that have more than two factors. So examples include
Oh,
so we have 4,
6,
6,
8,
8,
10,
10,
12,
12,
14,
14,
86.
15, and 86. Okay.
Yes.
Now 4 has how many? Has 1, 2, and what? And 4. So what are the factors of 6?
1, 2, 3, and itself.
6. Okay. Then 8.
1, 2, 4, and itself.
And 8.
Yes.
9 is a composite.
Then 10.
1.
9. Yes, we skipped 9.
Oh, yeah. Yeah. 9.
So 9 has 1,
3, and
9.
itself.
Then 10 has
1, 2, 5, and 10.
and itself.
and 10. Okay. So here we are saying that all these numbers have more than two factors, and therefore they become composite numbers.
Yeah.
Okay, let's proceed. So we go to finding prime factors of any number. So we have seen that prime numbers are those numbers that have two factors. Okay. Now, when we go to finding prime factors of any number, so we express that number in terms of its prime factors. And I think this one, some of us studied in primary, and some of us might have studied them in senior one, much as we have spent there some little time. So I'm saying in your primary, you studied about multiples and factors of numbers. So when numbers are multiplied together, their product is called
Multiple.
a multiple. So those numbers that we have multiplied to give us a multiple are called the factors of a multiple. Okay. So a multiple has two or more factors, as we are going to see. So let us begin with 12. Okay. So 1 times 12 gives us 1 times 12 gives us
12.
12.
12.
2 times 6 gives us
12.
3 times 4 gives us
12.
12.
Are there any other numbers we have left that we would multiply and they give us 12? Are there any that we have left out? Okay.
No.
So now our factors, remember we are dealing with factors, are these numbers here. Okay. So these ones are factors. Then this 12 here, we call it
Multiple.
a multiple. Okay.
Yeah.
Now we can say,
Unmuted. And the internet, the connection is unstable.
Okay.
the connection is unstable.
Yeah, it's like that.
Yes. We can continue. So the factors of 12 are 1, 2,
2,
3,
3, 4, 6, and 12.
and 12. Okay. Then now we can now find the multiples of 4. So we begin 4 times 1 gives us
4.
4,
4 times 2.
4.
4 times 2 gives us 8. 4 times 3.
12,
4 times 4.
16,
Then 4 times 5, 20.
20.
I think this was supposed to be 4 times 6.
Yes.
And therefore, okay. So we can
Yes.
conclude and say that the multiples of 4 are 4, 8,
4, 8,
12, 16, 20, and 24.
and
20, and
24.
24.
Okay.
Yeah.
So doing that same process, okay. Now get your books and pens and write this exercise. And we are giving each number 1 minute. Then after we shall come back and say our answers. When you finish, you are free to put your hand up. Anyone who has finished?
No?
Sure.
Yes.
Okay, finished number 1.
Yes.
Okay, what are your answers?
Number 1 was
1.
1,
Yes.
2, 3, 14, 21, and 42.
14.
21,
Yes.
21,
1,
42.
Okay.
Yes.
2,
In number 2 was
Excuse me, you're missing some in
1.
number 1.
We are missing something on number 1.
Yes. You're missing,
What is that?
7.
it's 1, 2, 3, 6. You're missing 6 and 7.
7.
number 1, you missed 6 and 7.
Okay, we have corrected that.
You missed
Number
6
2.
and 7.
Yes, we have written it. We have written it. 6 and 7.
Yes.
Number 2.
You have 1.
May come 1.
2.
2,
Yes.
4.
4,
7.
7,
8. 14.
28.
28. 56.
56. I hope we have not missed any.
Yeah.
So 56 divided by 1 is this, divided by 2 is that, divided by 4, that. Okay. The number 3?
1.
1,
2. 2.
2, yes,
3.
yes,
4.
yes,
6.
6.
yes,
9.
9.
yes,
1.
12.
12.
yes,
18.
8.
36.
36.
thank you, thank you. Number 4?
1.
1,
2.
2,
3.
3,
4. 6.
6.
yes,
9. 12.
12.
12,
24.
No.
18. 18.
18.
Yes.
27.
24.
27. 27.
24.
24
That piece of it
divided by,
is wrong.
no, 24 is wrong. When you divide, you get a positive, you get a point.
Yeah. 36.
After 26,
36.
54.
54.
And 108 itself.
108.
and 108.
Yeah.
Okay, okay.
Stop that.
So now the previous method, we just found factors. So for this part, where we have prime factors, so we are going to find the prime factors. So our example 1 is saying express write 36 as a product of its prime factors. So we begin by drawing a simple table. Okay. Those who are making some noise, please. So, and in that table, we write prime factor, and then we write what? A number. So our number is 36. So we shall begin with the lowest prime factor, which is, what is our lowest prime factor?
2.
2. So we begin with 2. So 36 divided by 2 gives us?
18.
18. So is 18 still divisible by 2?
Yes.
Yes.
Yes. So we again divide by 2, and that gives us?
9.
9. Is 9 divisible by 2?
No.
No. So
No.
we go to the next prime factor. And what is our next prime factor? 3. So 9 divided by 3 gives us
3.
3.
3.
So we divide by 3 again and it gives us 1. And from there we say 36 is the same as 2 times 2 times 3 times 3. So there we are expressing it as a product of its prime what? Factors. And we are saying this method of determining prime numbers is called prime factorization. Yes. Then we have this exercise here. So we 108. Can we do it together?
Yes.
Okay. So we draw our table. We put 108. Is it divisible by 2?
Yes.
Yes.
Yes. So 108 divided by 2 gives us
54.
54. So it is still divisible by 2. 54 divided by 2?
27.
27.
27.
Is 27 divisible by 2?
27.
No.
No.
No. So we go to the next number, which is 3.
3.
27 divided by 3 gives us
9.
9.
9.
9.
We
9.
still divide by 3. And that
3.
gives us
3.
3.
divide by 3
3.
and we get 1.
1.
Okay. So we're going to say 108. Okay. Is the same as the 2 is appearing 2 times. So it is 2 times 2. Then times 3.
3
3 times
times
3
3 times 3.
Times 3.
times 3.
Okay.
Yes.
So should I continue or you want to first write it? Okay. So we continue.
Yeah.
The next one is 64. 64. So we begin with 2. Give us
32.
32.
32 divided by 2.
16.
16. Divided by 2.
8.
8.
8.
8.
Divided by 2.
4.
4.
4. Divided by 2.
2.
2.
2. And finally
1.
1.
1. So 64 is the same as 2 appearing how many times?
4.
5.
1. 6.
5. 6.
6, eh?
6.
So 2 times 2 times 2 times 2 times 2 times 2. Do we have any other format of writing this?
6 times.
We can write it as 2 to power
6.
2 to power what?
6.
6.
Yes. So these other 2, you write them down, you do them there. Okay? So number 3 and number 4, you do them at home. I will take your answers next time when we meet. Okay?
Yes.
Yes.
Okay, so that is what I had for you today. Let me briefly to talk about the services that we offer at Yaka. So one of the services is the online classes when you subscribe.
Excuse me, teacher.
Yes.
May I see numbers 3 and number 4?
Okay.
Okay, thank you.
You're welcome. There is somebody having some loud sound. Can they mute their microphones? Okay, thank you. So I was talking about the services that we offer apart from these free online classes. So we have online classes which are 500,000 per year. That is paid once in a year. And this includes student-teacher interaction, like these ones we have, access to courses or subjects on the website, and the website is yaka.cc. Then there are assignments and quizzes that you do, which we mark and grade. And after a year, we promote you to another class and we give you a report card. Then have downloads. If you want to download a subject, it is 10,000, a single subject. Then all subjects for primary per class. For example, if you want P1, it is 30,000. When you come to a subject in secondary, for example, senior 1 mathematics, okay, no, all classes, okay, like all notes for senior 1, it is 50,000, okay? That is for yaka.cc. Then we have another one, which is at Educare. So which we find at www.educare.bz. And that one has 4 membership levels. So the first one is bronze level. And that one you pay 20,000 per month. So that one is for those who wish to pay monthly. We have silver level, and that one is 50,000 quarterly. For every 3 months, you pay 50,000. Then we have gold level, which is 70,000. That one is for half a year, 6 months. So that one you access content. Then we have platinum, which is 100,000, and that one is per year. So you access content per year. And this content includes notes, includes videos, and also includes audios. Thank you very much for listening and for your active participation. God bless you.
Thank you.
Thank you, teacher.
You're welcome.
Thank you, teacher.
You're welcome.
Thank you,
Thank you,
teacher.
teacher.
You're welcome, please.
Thank you, teacher.
Welcome. Thank you too for attending.
Thank you, teacher.
Thank you too.